Yes, my dear students. We are move on to the derivations, which consist of AC circuits containing RC series. In that circuit, we have R and C. R and C both are in series, and similarly, what you have done in case of R and L. So those things we are writing. So as V is equal to Vm sine omega t is applied given to this system, and R is and C are both are in series. So voltage across R is VR and voltage across C is VC. Like this they are connected and current flowing through that is I. Now, so as we have done, so what you have to write is that AC circuits containing AC circuit containing resistance R, resistor R and capacitor C in series, and supply of V equal to Vm sine omega t is given to the circuit, and current I flows in circuit. Current I flows through the circuit. And what happens? And voltage drop across R is VR, and voltage across, because in case of resistance there is a drop, but in case of capacitor we don't have any drop here. It will store the energy. That's why we are calling it as voltage across capacitor C. We cannot say it is drop. It is the voltage across capacitor C is VC. Now, so if you want to plot the phasor diagram here, phasor diagram we can plot like this. Phasor diagram like this we can plot. First we can plot the resistor phasor diagram. In case of resistor, what happens here? So current is in phase with the resistance. Current is in phase with the voltage. So it is the current I, and VR is the voltage across resistance. Both are in phase. Both are in same. It is the phasor diagram. In case of capacitance, so current leads the voltage by angle 90 degree. Current leads the voltage by angle 90 degree. So if you take I is the reference here, because I is similar in both cases. So I we are taking reference, and so we can draw like this. It is the VC. It is the VC negative. It is in negative direction. It is in negative direction. Current leads the voltage by angle 90 degree. Current leads the voltage across capacitor by 90 degree. So we can say if you make like this, we'll get total V. So VR plus VC is a phasor addition. We are making the phasor addition now. So VR plus VC together will make the total V. VR plus VC together will make the total V. So it is angle phi. It is angle phi here. It is the phasor diagram. Next we have voltage and current equations we have to get here. So here there is a triangle. Can make a triangle here. OAB. Can make a triangle OAB. From triangle OAB, so we can write like this. OA square is equal to OB square plus AB square. According to Pythagoras theorem it is. So what is OA square here? It is total V square is equal to OB square, nothing but what? Voltage across resistance VR square plus BC square. So you can get like this. What is VR here? It is nothing but what? I into R plus it is nothing but what? I into XC whole square. It also square. So we can take I square common. Inside we'll get R square plus XC square, as you have done in similarly in case of inductor. It is the V square it is. So if you take V this side, if you remove the square root, we'll get the I square R square plus XC square. So square root and square will cancel here. We'll get this much R square plus XC square. That is the V. So you can write like this: V is equal to Z is equal to I into Z, where Z is impedance. P by I. Z is the impedance. Even we can draw the impedance triangle also here. From this triangle we are nothing but what? It is I into R. We are nothing but it is I into R. It is nothing but what? I into XC. So if you remove the common thing I here, we'll get impedance triangle like this. It is the R, it is XC. From this we'll get the Z. Angle phi here. Like this we can get the impedance triangle. We call it as impedance triangle. Next we have waveform. How to draw the waveform here? Waveform we have to plot. Waveform. So it is similar to the in case of inductor. So first we have to draw the voltage. It is omega t. It is I and V. Both we are drawing. It is 0. It is pi. 2 pi. It is the pi by 2. It is 3 pi by 2. It is the voltage equation. But in case of capacitor, what happens here? Current leads the voltage by angle 90 degree. Means what? Current will start first. After that, voltage will come. That's why we have to draw like this. So it is angle phi. Because in case of pure capacitor, it is 90 degree. In case of pure capacitor, current leads the voltage by angle 90 degree. But in this case, it is addition of resistance and capacitance. It is addition of R and C both. That's why we cannot say it is exactly 90 degree. It is less than that. How much it is? Angle phi. It is less than that angle phi. It is making angle phi. Current leads the voltage by angle phi. So like this we have to show here. It is the current. It is the V. So you can write voltage equation, current equation like this. So V is equal to Vm sine omega t. So I is equal to Im sine of omega t plus phi it is, because it is leading. Current leads the voltage by angle phi. So that's why it is positive. We're writing positive. So instantaneous power we can draw here. We can write instantaneous power. So P is equal to V into I. So it is Vm sine omega t and Im sine of omega t plus phi. So similarly we can apply that formula, sine A into sine B. Sine A into sine B is equal to 1 by 2 cos of A minus B minus cos of A plus B. If you apply this formula, we'll get class similar as you have done in case of inductor, that equation will get. So similarly, so P will be equal to V into I, that is equal to Vm Im 1 by 2 cos of phi will get. So it will be equal to E RMS I RMS cos of phi. So just you go through the previous video regarding this, you will get the idea why it is RMS. We are 2 is dividing by into root 2 into root 2, like this we have done. Just to recall the previous video, you will understand the things. So now power, instantaneous power will be equal to P is equal to Vm Im cos phi, as similar to the RL series equation. This much instantaneous power we are getting. So we have got this RLC series diagram, this phasor diagram, this on impedance triangle, and waveform we have drawn, and instantaneous power equation we have got. At last, one more thing just we can add here. So phase angle, calculation of phase angle here. So calculation of phase angle we can make here. How to calculate? From this diagram we can do that. From this diagram we can do that. Phase angle. So tan phi, you can calculate tan phi here. Tan phi is nothing but what? Tan phi is nothing but, it is nothing but opposite by adjacent. Tan phi nothing but opposite by adjacent. Which is opposite here? Opposite is minus exc. Which is adjacent here? R. So tan phi is nothing but what? Minus xc by R. What is xc here? Omega c. Nothing but what? 1 by omega c by R. So similarly we can calculate cos phi also. Cos phi nothing but what? Cos angle nothing but what? It is the opposite by hypotenuse. It is R by Z. R by Z. It is the R by impedance. Like this we can. Cos phi nothing but it is power factor. We'll come to know what is power factor. We'll study that. Power factor. Like this we have to get the phase angle calculation. It is the power factor calculation. Like this we have to get the equations. It is about the AC circuits containing RC series. It's a derivation. Just to note down this one, we'll get the idea.